Right, we are now recording. Wait a few more. Okay, I'll wait a few and get going. When we get, I will sort of break and do the necessary announcement thing when we get enough people on board. In the meantime, this session is going to be, in a way, a continuation of what we did last week, last session, so Tuesday. Gosh, I'm always so confused about that. Because it was suggested to me that maybe a picture to assist in the process of understanding how it all ties together and how we went through the debug routine might help put everything in a better context. So I did that little drawing. I modified one existing one and did a little bit of fancy footwork. And please, it is essential with this thing that if you have questions, please ask them, because otherwise I don't know what answers to give. I'm going to move through this from a different perspective, and hopefully it'll all come right. Now, the first step that happens is, now, where am I? Let me just, we had a test program, which was this one that you can see here, this code. You saw it last week, Tuesday, and it had populated 3 fields in the file and then issued a call to a I/O server to do the insert. Now, if we come back here, what actually will happen is that call to the customer test program is what initiates an activation group, because that customer test program was compiled using an activation group new and a start commitment control change. As a result, the whole thing has now opened a new activation group. So everything that happens from here is going to happen in the new activation group, as long as the programs and procedures that are called from this point onwards have activation group star caller. Then there will not be another activation group opened. And in the case of this test program, that is exactly the case. So the next thing is that this test program is going to call the I/O server. Now, the I/O server is a procedure in a service program that is custom built to service the I/O for the customer master file. So the call to insert will actually initiate a request on the database management system. And from there, something strange happens, which is illustrated definitely in terms of the debug that we went through. But in the diagram, it looks a little different. The relational database management system will immediately check the file definition, and if a before trigger or triggers is defined for that event, it will issue a call to the trigger program, which is there. This is a program. It's compiled as a star caller. Please be very careful about that. A trigger compiled with a star new or a named activation group can create untold consequences, some of which are completely unpredictable. So trigger programs must always run in the caller's activation group, which is in fact the activation group of the program and its procedure, because this is compiled using star caller as well. So everything happens within the one activation group. Now, the before trigger program can respond in one of two ways. It can respond by just passing control back to the RDBMS along that blue line, saying, I found nothing wrong, and therefore you may go ahead. The other option that it has is it can use an error handling procedure or whatever methodology that you find suitable to actually send a diagnostic and or escape messages back to RDBMS. If the trigger program sends back an escape message, which in the case of my error handlers is ERR11, sends an escape message, nothing further happens. RDBMS passes control, passes that error message back to the caller, which is the IO server procedure, and the IO server procedure simply percolates that back to the calling program, and the calling program, which is the test program, as we have seen, skips the commit statement, no commit is done, and it percolates it back up to Q command. So the message will actually end up going up this line back to Q command. Now, in that process, an exit occurs from the activation group, because once this program here, test, terminates, once this program terminates, it effectively terminates the activation group because it's a new activation group. That's one reason. But there's also a second reason why this activation group would terminate, even if it was named. And that is because the control has been passed back here as an escape message, star escape message. And an activation group that is exited via an escape message will be closed down and reclaimed. So there's two reasons why this activation group would be reclaimed under those circumstances. So if there were error messages going back, that's all that would occur. Any updates would have been rolled back, and all files would be closed, all programs would be terminated, and control would be returned to the command line in the case of our little test, and the error message ends up on the bottom of the command line. However, if the trigger does not send back an error message, but rather just acknowledges, I'm happy, what happens is the RDBMS will actually write the record to the customer master file that was requested by the original, by the original IO server, and the record will get written into the customer master file. That record, having been validated by the before trigger, will be written into the master file, but it will still be under commitment control, and it will still be locked, i.e. it will not be accessible to any other program, any other job, except this one. This one, which created the lock, still has access to that record. No other job will have access. So once the record has actually been placed on the file, the next thing that happens is RDBMS will call any defined after triggers. Now, in our case here, we do have an after trigger. This after trigger was designed to actually add, on insert, to add a balance record to the balances file. So actually what happens is that this trigger program will call the IO server to add or insert a record onto the balances file. Now we saw that here. There it is, populate the record and call the IO server for insert. This, by the way, is not another instance of RDBMS. It's the same instance of RDBMS that is used by the entire system. It's just that writing it there again makes it easier to read. So the request for insert will then go through the RDBMS, and because this file has no triggers, we won't get the same action as we did in the case of the customer master file. However, it is quite possible that this balance file, or any file that gets called from a after trigger, or in that matter from a before trigger, will each have a before and an after trigger. It's possible. And so you can see that this diagram that I'm drawing here could expand out to the right-hand side quite a long way. And this is something that the database designer has to be very careful of. And we will look at that in a moment when we highlight the end of this process. So that, no triggers involved in the customer balances file. As a result, the record gets added to the balances file, but, and this is a but, it will still be under commitment control because the balances IO server has got that file under commitment control, and because of this commitment control cycle that we're currently operating in, the record that is added to this customer balances file will still be under commitment control and will still be locked. So both of these records that have been inserted, one directly by the test program through the IO server and the other one through the trigger, are both in the identical state. They are on file, they're locked, and and still uncommitted. Then the next step is possible. Now, this process very rarely happens, and one must be very careful about sending back error messages from an after trigger. It should not be necessary, because an after trigger generally is working with a file that has already been validated. But there are instances, particularly if downstream from that after trigger we are synchronizing files and doing other things, there are instances where an error could be percolated up through here. And it will then be passed to the RDBMS, and the RDBMS will then pass it back to the IO server where it is monitored and passed back to the application program. Now, the application program must understand that this has come from an after trigger. If it percolates that escape message or that error message, a rollback is going to occur. That means everything that was updated, no matter how far downstream to the right-hand side we've gone, all of it within this activation group is going to be rolled back. The one thing that trigger programs must never do is a trigger program must never issue a rollback or a commit. Never. Because a trigger program cannot, in the context of where it is, be sure that a transaction cycle is complete or needs to be rolled back. Similarly, the actual I/O server procedures, that one and that one, they must always put the file under commitment control. Always under commitment control. But they must never issue a rollback or a commit from inside the I/O server, because there's only one part of this whole jigsaw puzzle that can make a decision as to whether the transaction cycle is complete, and that is the actual application code itself. Only the application code knows that it has completed the updates, inserts, and deletes on all the files that it needs to. And so it is only the actual application program that can issue the commit to say, I'm finished with this transaction. Of course, it also can issue a rollback if it gets an error which indicates that something has gone wrong with the transaction. In the case of my little test program, I don't bother to do that because I immediately exit the activation group, and that means it's going to roll back all by itself. However, the application program may be 4 programs down into an activation group. And at that point, the decision is made to roll back everything. And a rollback can be issued from inside an application program. But never from a trigger program and never from an I/O server program. No commits, no rollbacks. Because that's not where a decision can be made. Now, like all the rules I throw out, there are exceptions. There are always exceptions to every rule. And you might, at some time in the future, apply the rules and find it doesn't work for you. But it's a good idea to apply the rules first and only come up with the exceptions afterwards. And it's very important that if you have to come up with an exception that is not standard to what you have decided to do, you must document it properly. Because always the problem is that 6 months, 12 months down the line, when somebody looks at this and says, what on earth is happening here? If it's not properly documented, mistakes can be made. And I speak from experience. I mean, I do it myself. I look at stuff that I wrote a year ago and I say to myself, the guy who wrote this was nuts. It takes me 10 minutes or so to realize that was me. And I was nuts. But nevertheless, not documenting it properly makes it difficult to actually understand precisely what is and what isn't happening. Now, as you can see, this could go on. The balances file could have a before trigger. It could have an after trigger. There might even be, in the after trigger of the customer master file, there might be another call to a piece of application code to pop up an address window asking for addresses to be input. Remember, we have a customer address file as well. If the business rules require at least one address, it can be implemented and enforced by the after trigger. Doesn't have to be implemented and enforced by the application code, depending on the circumstances. So I would, when you're starting out with this, I would consider, and this is when I was drawing this little diagram, I thought to myself, you know, this is actually not a bad thing to do when you're designing things around database files, is to actually do it like this, in little boxes. and show where the triggers are and what the triggers are actually doing. It might help with the big picture as one moves forward. Okay, this is the picture of what we went through using the debug. But it did occur to me that I showed you an error. Oh, sorry, there's some more coming here. Once the after trigger has returned control back to the RDBMS, the RDBMS will then check any defined constraints. There's one there, and there's one there. Those constraints then get checked, and if they are okay, then control is passed back to the caller and back to the application code with no error messages being issued whatsoever. But any problems that occur here in terms of referential constraints, we saw what happened on Tuesday when there was no rep master record for the particular rep code that we'd put on the customer master. So that is, and I'm just going to discard all the ink so that you can see the slide clearly, and we will just leave it up there so the recorder can take a little bit. Before I decided to do the debug route again. But this time, I want to actually create an error that is picked up by a trigger, because it occurred to me that the error that I showed you and the error that we had came from this referential constraint. I would like just to run through the whole process again, but this time I'm going to change something in the code in this test program, and I'm actually going to put in a blank as the customer name. Now, that, let's compile it quickly. Is going to create an error in the before trigger program. Oh, okay, I have forgotten to set up my library list, so of course I'm working with a library list that won't allow me to compile that. But remember, while that is being set up, the before trigger, the validation here says if the customer name is blank, create an error and send back that particular error. So let us just go through this. If I can get this to compile, let me just set the library list up. And hopefully that will compile it. Yes, it has compiled it, and hopefully, all being well, I will actually get the debug. I've set the service entry point for the debug. Just waiting for it to come in. There it is. We've got the service entry point. Now I will have to bring this in, edit the library list, and put in that, which should be all I need. And then I'm going to call and hold thumbs that we don't get the same problem as we did last time, and we didn't. We immediately kicked in the debug session, and I can get that out of the way, and we can now look at what happens when we go through this. We have got a situation now. If you remember correctly, we did add rep code 44 to the rep master file. As a result, we're not going to get an error out of that anymore, but this cus name is going to give us a trigger error. So let us go through this, and I will go into the IO server. I'm also going to do something that we didn't do yet on Tuesday, and that is to actually show you how the error percolates from within the service procedure that actually does the error percolation. Here we are. It's not open. We open the customer master file, set up the pointer. We've discussed all of this, so I don't have to get overexcited. And here I've got a put that is going to insert the record. I will step into that routine. There it is. And it will find for me the next customer number, which I believe should be 5. Yes, it is. Set the date and write the record. I will step into the before trigger. Now, we are in the before trigger. Anybody wants me to slow down, just send me a message. Right. Insert the default routine is to set up the record status as blank and the user ID as user, which it happens quite normally. The insert event allows us to set up the start date, discussed on Tuesday as well. And then we come to the validate routine. Now, the validate routine now is going to behave a little differently to the way it did before, or it should. If it doesn't, then I'm very upset. But here we reset the error indicator within the trigger program, and we check customer number is not 0, I'm happy, etc. But when I get here, I've got a condition which says the customer name is blank. Now, that means I have encountered an error condition within the trigger. So the first thing that has to happen is I've got to flag that as an error condition, i.e. one error at least. And that's what this error indicator indicates, that at least one error has occurred in the trigger. There could be more. There could be many. If it's a long record, you could have a dozen errors. The important rule is to try in one pass of the trigger to trap as many errors as you possibly can. It does mean turning the error indicator on more than once. It's a little bit redundant, but to me it's better than saying if error is on, if error is not on, turn it on, otherwise don't do anything. That just doesn't make sense to me. And we use this error handler. Error 10 outputs a diagnostic message. The message that it's outputting is that one there. That's the message ID from the message file, and this is variable message data for that message. So I'm going to step into this particular error handler. It's one of the standard error handlers that's available in the open source, and it's been around for an awfully long time. In fact, it's the module error services 02, and the procedure is error handler 10, send a diagnostic message. The message ID is TRGB100. The message file has come through as error message file, and the message data has come through as stomer name. So I've got an alignment problem there somewhere. That's cute. That really is very cute. Okay. The trigger is an optional. The target, the message target, is optional and was not passed through. Customer name is the third parameter in that call. This is 120. That's where the problem has occurred. This is, I'm using that, and then this one is actually 2048 bytes varying. So that's where we've lost there's a misalignment here. Okay, this is the new version. The one I have in the trigger is actually defined using an old version. I must fix that up before we carry on next week, but that's not a problem. Right, so here we are in this error handler. If there's only one, there were 3 parameters, so it's going to jump past that. If there were 2 parameters, there were 3, it's going to jump past that. If there were 3 parameters, please understand that when you are defining parameters that are specified as optional, you have to code the receiving program to make sure you don't refer to an optional parameter unless you know it's there. Because otherwise you will get the standard error message which says pointer not set for location referenced. That's pretty much standard. If you get that message, you will know that you are trying to refer to a parameter that was not passed. Okay, we good. If the address of MF is not null, we create the message file and we put in library list. So we create the message file. MFL is in fact the error message file in the library list. Just as a matter of interest, the address of MF, which is a parameter, yeah, there's the parameter. If the address of that is null, it means it was not passed. You can see it's an optional parameter. And if the address of that parameter was null, it means that parameter was not passed. So that is another way of testing to see whether the parameter has been passed or not. The reason for this trick is I can actually pass MD without passing MF, because MF is optional, MD is optional, but I can skip that one using a star null comment. Sorry, star omit. In place of the second parameter, I can put a star omit, and then I can use that trick to test and see whether in fact it was passed or not. So let me continue. Here we go. MDL is the length of MD, the message data. My goodness. The validation is actually broken. For what reason? But ERR10 has failed, and that's why I've dropped into the on error condition here. Very puzzled, but let me go back to this call here. We can do a shift escape, pick up a 3, look at the job log, and see. Okay. There is the reason why I got a failure in the error handler. This is just to prove that things do go wrong. The length of the varying length variable is out of range. And that is very obviously caused by the fact that the call from the trigger, that call there, has a third parameter which is defined as 128 bytes fixed length, whereas the actual procedure that received the call had the third parameter of 248 bytes with a variable length parameter. So the first 2 bytes are actually the length of that field. And that is why I'm getting a variable length out of range. So what we have here is a definite example of the fact that I shouldn't have showed you in this particular problem, because it has created another problem in that I have defined my error handlers incorrectly. It's my own fault. I changed the data standard, the length of the field. This is a good lesson, because I felt that 128 bytes wasn't enough for some of the variable data that I wanted to put through to particular messages. So I upped it to 2048 bytes to give me plenty of space to pass variable data for an error message. In fact, I made it as big as that because I can, if I wish to, I can pass entire records to the message manager as variable data and design my messages to pick out fields from a record. Now, I said that, and I would like, if anybody has a question about what I've just said, please ask it. Or at least tell me that you don't understand what I said and that I must say it again. Are we all comfortable with the use of predefined messages and variable message data in predefined messages? If you're not, please say so. Okay, I must assume from the silence that everybody understands that I could define a predefined message. I could receive message data, which is an entire record, as long as in this case it's less than 2048 bytes. And then I could customize the variables with fillers to actually pick out of that record those pieces of information that I need to appear on the message. That was the reason why I made it that long. And unfortunately, I didn't cross my I's and dot my T's, so the before trigger is defined incorrectly. The before trigger should actually have the error handler. I'm looking for it now. Where is it? There. That one should be 128, and so should that one, because in fact error handler 11 has exactly the same definition. So those two triggers I'm going to have to change if we're going to get them to work. But here is a good example of why the idea of percolating error messages is a very workable option. Because I have picked up, quite by accident, an error that I didn't expect. And what's happened is this particular routine has failed and has dropped me into the on-error condition. There. That's going to be the next thing that happens. This error handler is going to percolate the message up one level. Now I'm going to go into that again, and I will pick up a different module. Hopefully this one is defined properly. The percolate, which is the most used module or procedure in the error handling set, only has a target, doesn't have any of the other information. Its job is to move the diagnostic messages up one level in the call stack and resend the last escape message. So that's the job of this particular procedure. And it checks parameters. If it's less than 1, it means the target was going to be defaulted. I look for the call stack entry that I'm going to send it to, which, by the way, will always be 2, because I'm looking at the call stack from the error handler, which means call stack entry 1 is the program that called the error handler, and that's where the message is. So I want to move that message up 2 in the call stack by default, not just 1. Otherwise, I would be sending it back to where it was. Move program messages. And resend escape message. Those are the 2 APIs, system APIs, that are used in this case to move and resend the escape message. Now, resending an escape message is equivalent to exiting the program immediately. And as you will see, it did exactly that. It exited the error handler and went straight back to the on-error condition in the trigger. So I'm now dropped into this error message. Now, this error message here actually says an unexpected message, an unexpected error was found in trigger whatever name. So this now is the message, is the error message that is going to be sent from the before trigger through the error handler, error 11, to the relational database management system. It's going to say an unexpected message was encountered. Let's see what happens. I'm going to just step through that. It's interesting. I've got a debug engine message. Program received unauthorized, unmonitored exception. RNX 0115, length of varying length variables is out of range. Interesting that it actually threw out an error because it wasn't monitored. And there is another extraordinary thing. I don't have a monitor message in my error handlers. Never have. I've never actually monitored for error messages in error handlers. So what has happened is I've got an error message that's come up and said I've got an error message that is not monitored because the error occurred inside an error handler. Now that will be percolated by the operating system. So I will step through, and I'm back here at the I/O server in the on-error condition, and I will percolate using error 03. I will percolate that message up one level, which will take me back to the I/O server itself, the main I/O server, and again we will percolate that error up to the test program, which will percolate that error up to the actual command line. Now, what is important to understand here about this percolation of this error message? I had no need to identify what that error message was. I did. I went and looked at the job log halfway through because I was puzzled by the fact that it had pitched up at all. But I have no need programmatically to identify that error message. I know it was significant because it was an escape message. And I passed it on from where it occurred all the way up the call stack until I got to CUS test. And that one is going to percolate it again up to the command line. And what I'm getting here is application error RNX 0115 unmonitored by error server at statement, error services. Now, that is the last error message, the one that was unmonitored, but it's still percolated up with the system without the application program having, or even the triggers and all the other stuff, having to be aware of actually what had happened. Now, at a point here, I would then press F1 and I would see the job log message. This application ended abnormally, etc., etc. And when I press F9, I can see that it came from there and it was sent to there, which is the menu driver. I can also press F10 and I get, because I have been percolating messages up the job log, I am seeing the whole lot. An error in the trigger program was detected before write on file cusmast F. If I do an F1, that's an RNX 1023, the trigger error. Error occurred in trigger program, 502B. Error occurred in trigger program, 502B. These are all errors that are percolated. And then, of course, application error and length of varying length variable is out of range. So I never got to the point of checking to see whether my customer name was blank or not, because I made a mistake in my coding, simply because I changed the rules on myself and didn't check what was going on. And this is an illustration of the fact that you get this massive flexibility and capability, but there are things that can bite you as a result of it. Now, what I'm going to do is I'm going to illustrate something else now on the fly. By terminating this debug session, going back to my before trigger. Now, the before trigger is a program. The before trigger is linked to the database file at the time that the trigger is defined to the file. And in order to do that, you need a lock on that file. However, once you have created the relationship between the trigger program and the file, i.e. you've created the trigger definition. The trigger is an ordinary program. And therefore, I can change a trigger program and I can put it into production without having to have a lock on the file. And this is very important. And I'm actually going to use this now to demonstrate exactly that, because I am often asked, why is it, or triggers have this particular problem, that you have to have locks on file if you want to put a trigger on the file. Only the first time. You can change triggers after that without having to do that, and I'm going to prove it. So let's just have a look at this 10 and 11. I want a constant varying omit no pass var size. That's what I want. I want that parameter in the trigger definitions for this one and for this one. So I've changed the definitions, the parameter definitions of those two calls to conform with the error handlers that I'm using. The error handlers are service programs. They will be called with whatever parameter list I give here. So I can compile the BI trigger, the B1 trigger. Compiles perfectly successfully. I must make the same changes to the after triggers to be absolutely certain. Now, the after trigger, there's only the one, and that's this escape message, and we will put that there, and that then creates the same, and we will then compile the after trigger. Now, because the after triggers and the before trigger have now been recompiled, and because the cust-test program was the beginning of an activation group, which I have now exited with an escape message, the trigger programs have been closed down and the resources have been recovered. Just like an ordinary RPG program, which you can change while a job is using it. But that job will continue to use a cached version of that old version of the program until that program is terminated. The next time that program is called, it uses the new copy. It happens exactly the same with triggers. And because I have closed them down, the next call to cust-test should, and I'm always a little bit cautious here, should actually use the new versions of the triggers without causing any issues. So what I'm going to simply do is I'm going to simply go up there and press enter again, and we should get back into the debug routines, and I'm going to zip through them as fast as I can. Here we are. We got a blank customer name. We're going into the IO server. Now you'll notice it does the open again because it has been recovered. Okay, we'll get into the put routine. Come down here. Because the last one failed and a rollback occurred, we should still get 5 as the customer number, which we have got. And we can then write the record by stepping into the before trigger. And here we go again. Let's hope this time we have a slightly more successful attempt at this. Just to be sure, I'm going back and I'm looking at the error handlers. There they are. There's the change. So I've actually got and gone into the debug in the new code for the new trigger. I did that without having any need to lock the files or unlock the files or release the files. So let us see whether, in fact, the error that I was planning to do in the first place. I'm not going to go through the default. I'm going straight into the validate, and let us see. Yep, there's the error. Now error handler 10, let's hope this works. I'm stepping into that as I did the last time. And parameters were 3. So I set up the message file and I send the program message. Now that is error 10. This is a diagnostic message. It's a diagnostic message. You will see that the send has a diagnostic. Error 10 is a diagnostic message sender. I just do that so that there are fewer parameters that the application program has to remember. So it sends a diagnostic message, and that goes back to call stack entry, which is in fact the RDBMS. I then return, and so this has sent a diagnostic message, and I have an error handler on. So now it's behaving properly. It's what it's supposed to do. We step through this, and we go back to the main line, and the first thing we look at is if error. And error this time is on because I encountered a single error in the validation routines. So I will go into the error 11, which is now going to send an escape message. And I'm going to drill into that. And if we look at it here, it goes through exactly the same routine, pretty much, except this statement here in the error handler sends an escape message. And the minute some process sends an escape message, it terminates and exits. So in fact, this return statement here is redundant. It's not necessary. But if I leave out all the return statements, then the compiler says there is no way for me to exit this program because they haven't yet got smart enough to understand or identify a transmission of an escape message. Okay, so let us step through that, and we go straight back to the on-error condition in the put statement. Now notice what has happened here, which is of significance. I never went anywhere near the after trigger. I have come straight back to this customer master IO server. There it is, customer master IO server. I've come straight back to there, and I'm sitting in the on-error condition. So I never, because I sent the escape message, this one here, because I sent that escape message back to the RDBMS, it did not bother to look at the after triggers or anything else that was related to the after triggers. It returned the escape message straight back to there and left me in the on-error condition. This is where the percolate has a lot of power, because I still don't need to know what the error messages were. There was one diagnostic and an escape message. that was sent out by the trigger. We will percolate those, and it takes us up to the end of the I/O server, the on-error condition in the main line of the I/O server, and we will percolate that up to the on-error condition for the test program, and when I percolate that up, I will get the program has ended. But this time, the error message is different. Error found by customer master file B0, see job log for details, followed by an error in the trigger program was detected before the write on file cusmast F. Those are, if I do an F1, 10, F6 to show the IG, I have, there shows me that I have a problem. I have an error message file that I'm looking for that message in, but it hasn't been defined. So I need to go and define that message in the error messages file in order to have something that is a little bit more meaningful to the user than that. And this is also one of the reasons why this idea of using a test program and actually forcing error messages, forcing errors into the record to make sure that you actually have error messages, appropriate error messages for all the possible error conditions. Now, TRGB 100, let's go back to this. Where's the trigger program in the before? B100, TRGB 100. That is that one there. It should say that field customer name cannot be blank. That's what it should say. It says it's in an error messages file, so I need to look at the error messages file in AMWDB. And this is the sort of thing which I'm moving towards the next topic, so bear with me. I need an error message. So what I need to do is I need to go and I need to work MSG, work with message files in AMWDB *ALL. The important thing, you see, again, what's happened here is I changed the message file for AMW for the modernization workshop, but I forgot to change the code because the code says error message file. So let us just have a look and see whether, in fact, I've only got one message in there, which is not good. So I can add another message there. TRB 100. Sorry, TRGB 100. And I want to say the &1 field cannot be blank. That's a reasonable user message. And the variable there will give a name, but I'm going to actually also be a little bit smarter, and I'm just going to put it in quotes so that it's more easily understandable. And I can, at the same time, I can provide second-level message text, which will operate for me in exactly the same way as all the operating system messages operate. So I have created this particular message, Why didn't I create it? That's annoying. TRGB 100. Oh, I know why I didn't create it, and why has none of you sent me a message to say, don't be an idiot, but if you define a variable in a message, you actually have to define the variable. So what I have to do is I have to page down, and I have to define a length 2048, a character field of length 2048, and there I have my message. But this message is in AMW message file. So here I have an error, again in the trigger program. Message file. Right, so now we can compile the trigger program again. And this time I'm going to switch the debug off because I don't think we need the debug anymore. I have, unless you want me to, if you do, please say yes. But I'm going to turn it off because what I'm now looking for is to see that I get the right message at the bottom. So if we do this, there it is there. So what we have here is we have the trigger program, which is issuing errors, and also the diagnostics. If you look at this, you will see this one is actually a diagnostic error. And I could have a whole series of errors, diagnostics, followed by error found, etc., etc. This error found, I think this one, yeah, it's my own. It's a message ID I created, error found by that trigger program, see job log for details. And that is the one that actually comes up at the end because that is the escape message. Let's just check that. That is the escape message. No, that's oh, sorry, it's been converted to a diagnostic because there were subsequent errors. These errors are coming from the operating system itself, and those create this as a diagnostic. But this means you can pass all the errors that you can encounter in a trigger program. You can pass them back to the job log. And from the job log, depending on what you're using, you can pass them out to your display file in the simplest possible manner. And I don't know how many of you are using display files, and I don't know how many of you are using the message subfile functionality of display files. But message subfile functionality, when you define a message subfile and you specify in that display, you specify the program's message file, it actually pops them up on the command line on the panel exactly the same way as it does here. So you can achieve exactly the same result with a display file by using the message subfile processors. Okay. Before I move on to the next topic, I definitely want to see whether there are any questions. No questions. All right. You have my email address if you wish to do it subsequently once you've watched this recording again. I'm going to now move on to another topic. But before I do, I just want to let you guys know that of a couple of things that may or may not happen. I'm looking here, we are Thursday, there are two, it's the 18th and the 20th and the 25th. There are 3 sessions. 27th is a South African public holiday, and we won't have a session on that day. So there are, after this one, there will be 3, and then there will be another one on the 2nd of May, all of which I will do and continue with the Advanced Modernization Workshop. Then I may or may not have sufficient material to complete these sessions. What I will do is if I'm running short of material for a particular session, I'm going to cut the session a little short. I hope you don't mind. And we will have 4 sessions up until the 2nd of May. From the 4th of May, 4 sessions will be handed over to Nathan Anderlin of Relational Data, who will actually take you guys through what we've called AO Open or one-point portal, which is a tool that allows you to build graphical user interfaces based on file definitions, and he's going to base the 4 sessions around building interfaces for the database that we have been building up in the process, in the background of this little exercise. The customer master, the customer balances, the customer addresses. And he's going to illustrate how to create graphical user interfaces, and that will be in 4 sessions. And that starts on the 4th of May and will be the 9th, 11th, and 16th. Then on the 18th of May, the people at VR Tech will have a session just to introduce you to their product. And then the last one, I think, is the 23rd, which is basically the last session. It's a shutdown session. It's a review session. It's a hope you had a nice time session. But the next 3 or 4 sessions may be a little short, depending on how my material holds out. I'm almost convinced that Webex actually shifted in a couple of sessions when we were moving things around. But Marinas disagrees with me on that one, so I just have to take it as it is. Okay, so let's move on to the next topic. Naming and other standards. Then I'm promptly going to go back to this picture. If you can see from this particular picture that the actual application code involved in this little diagram is made up of that program there. Everything else, all the connections and all the ins and outs and backwards and forwards and updates and messages and everything else actually are outside the main line processes of the production system. And this is why we have to have a serious conversation about naming standards in particular. The other standards are about coding standards and style and utilizing things like the error handlers throughout. But the first conversation that we have to have is naming standards. Because it is only via the standard naming conventions that you apply in your processes, in your procedures, in your service programs, and in your other objects that give you a connection. If you called this trigger program Trigger 177 because it happened to be the 177th trigger that you wrote, I promise you that's going to come back and bite you badly. Naming conventions are the only way, and believe me, I have tried, are the only way of understanding how things fit together easily and quickly without having to go scrabbling through display program references and digging around in source code and so on and so forth. The standards that you build for naming, when you're talking about a database and database modernization, must be built around the file names. All of them. And even your display files that provide input screens to update files should also try and connect to the files or the functions or the procedures that they relate to. I can't stress this enough. You can see from my naming convention that I adopt a very rigid file naming convention. It has the first three letters of what I call the customer data set, and that collects all the files that belong to the customers in this case, or some logical set of data files. And I stress the word logical. Please be careful that you don't get too random on this one. Group your files by the first three letters. The second three, in my example, in my dummy database, as we have been working through this, I have used three letters as abbreviations for the type of file it is. I don't generally do that when I'm building databases, and I will show you specifically the convention that I use for building databases. You and your teams, I don't know whether there are 2 people or 102 people, you're going to have to agree on some form of standard going forward. You may already have a standard. Review it. Please do not change just for the sake of changing. That doesn't make any sense whatsoever. And also, consider that if you decide on a new standard, do not set up a massive project to retrofit. You're absolutely correct. Kay has just written, I think standards are one of the hardest things to agree upon. You're particularly correct, and particularly when you have a large group of developers. Put them all in a room, lock the door, and every single one of them will have a different opinion, and they will generally kill each other. It's a very difficult thing to do, which is why, in a lot of cases, somebody has to, either a small group, a steering committee, or if there's somebody around who can take the pain, an individual must make the decision about the standard, and then it must be enforced. Very often it's necessary to do that, because otherwise you will find problems. Let me just show you. I'm going to just show you the database. If I can get it to actually work. The first standard that I have is that my entire database, the source for my entire database, goes into a single source file. None of this, none of that. Because with RDI, and you are going to use RDI in the future, that much is going to happen because there's no justification not to. RDI allows you to sort things. And so my naming convention always starts in the left to right direction, and everything sits in a single source file. And the justification for that is this. Here I will sort it by name. RDI allows me this capability of sorting by name. Okay, I've got actually, this filter includes the development stuff. Let me rather get that out and get this. Source DB, showing table, there we go. Right. This is now, oops, I'm sure that everybody has a fixed program or two in their libraries, but this is the database production library for AO. It all exists in a single source file, and with exceptions, and like there are always exceptions to every rule. The first three letters indicate the data set. AOF, which is AO Foundation, is a big data set because it is the most. I have AOS, which is the source file data set. I have AOR, which is replay, AOL, which is logic. There will be others. So each of the first three letters produces a data set. It's a primary group. So I can filter, because they're all in the same physical file, I can filter by AOF. Now I'm looking at a complete set, one data set of records. Now, this is where we can get by type. We can filter by type. So let's subset by type. And somewhere here, SQL. These are the physical tables, the SQL tables that make up the AO database. All these tables, if you load the product, they will be there. They have text descriptions. and you can filter and sequence by type. They're all in the same source file. I'm looking at the SQL type. I can show all, but I can sequence by type. So I can see the CLs, I can see the logical files, I can see the RPG, but I also might be interested in knowing everything that belongs to AOF 180. Now, instead of using MST like I've used for our existing workshop database, I use numbers for the second 3 positions of a file name. I use numbers because I usually assign them 10 apart. I can then insert files where they logically belong. I also don't have to have the detail file always coming before the header file in the sequence. I can create, and that's why I use the majority of my positions 4, 5, and 6 are numbers. People say, oh yeah, but I can't have numbers. Nobody will remember what a number means. It's not true. It takes a very, very short space of time of working with the database and the files to begin to know what the numbers are. And in fact, in the AO database, I've been working with it for quite some time. The numbers are as clear to me as 3-letter abbreviations. In fact, they're clearer because I don't have any confusion, and they all fall nicely into a sequence that I can control. The other thing about it is if I want to filter and I want to look for all AOF 170s. Now, 170 I know is all the files, or is the file that carries field names for the AO definition. So I can actually filter that. And this is the reason why they should all be in one source file. I can then sort them in name sequence. And now I can see there's my physical table, there's its trigger, there's its IO server, there's a second IO server, which is used for another purpose. So I've got a double IO server there, logical file, IO server for logical file, a string of logical files all together in one source file in a sequence that I can actually pick out. And this is very much a standard for me that I've been using for years and years and years. And when I moved into RDI, it became even clearer that it was logical to have it all in the same source file. You've got the type code here. You don't need Q, DDS, RPG, LE to know that this is an RPG file. You don't need it. What you need to know is that this particular component belongs to the source for the database in that library, which is my production library. So type coding your source files was something that we did in the system 38 days. And you should move away from that as quickly as possible. And so you can get objects or components, both source and object, sequenced accordingly. I mean, if you look at this particular thing, but I look at all objects. Previously, I was looking at the source. I have the same benefit when I just look at all objects, because I can sequence by type code, so I can see my data areas, my files, and attributes. Of course, I've got see my physicals and logicals. And notice how all these are falling into place. 170 is the field element detail. 170FA is a logical file. So here's the next part of my file naming standard. First 3 is a data set. The second 3 are usually numbers, which allow me to sequence the files in the data set. The last one is an F, which stands for physical. That was before they introduced table, which should have been a T. But F, I've stuck with F. And by the way, it's F-I-Z-Z-I-K-A-L is how you spell it. F is my physical table. It's physical data. And so a physical data file in my standard environment is 7 characters long. Why is it 7 and not longer? The reason for that is I need those next 3 for other things, for other standards. And that is where I have a restricted length on the actual file name. Anything after the F, one letter, indicates that this is a logical file. So you can see that's FA, FB, FC, all the way down. There's a lot of logical files involved with that one. But they all follow very neatly, one after the other, after the physical file. If you use an L in place of an F, or if you use a P and then an L, you don't get them falling in the right sequence. So they become difficult to find and difficult to correlate. So one of the things that AO does is actually to do that correlation if you don't have a nice naming convention. Okay, so that's physicals. Now, everything else sort of gets based on that naming convention. IO servers are the file name with a $$ at the end. You've seen that. The module. Trigger programs. This is where I need the 3 extra characters. Underbar B0. That's a convention I've used for years to indicate underbar A is an after, underbar B is a before. And then I can number them 0 through 9, A through Z. So I can have lots of triggers if I want to. I'm not limited by the naming conventions. But they all fit and they all follow. So if I take AOF 031, I've got everything that belongs to that file together. Similar methodology applied to program code. One source file in production, usually called SRC because I'm extremely lazy and I don't like typing anything longer than I have to. So the file for my AO Foundation production environment is source, SRC. Again, the same similar concept. Production programs, 3 letters up front. Indicating a function, a group, a pack, anything that's logical. Let me just show you. AOF is some of the foundation. AOF was a mistake we made. These are related to. Here you can see we tried to create a standard using a prefix. It's part of the foundation suite, and a 4-digit number indicating a group within it. That became very, very tedious. So eventually we started this BLD says build, and DDL says build DDL. So we started a slightly different naming convention, but the concept is exactly the same. Everything in one source file. And if you use the same abbreviations, you can use them either at the beginning or in the middle. Take, for example, the CHK. If I filter that, I hope this is right, but I use stars on both sides. Okay, in this case, they're all in the front. So I can find the cross-check group or the check group. XCK, let's see if that gives me a better. So the idea is to build your naming convention so that you can. Okay, there's a good example. XCK is an abbreviation I've used for cross-check. And you can see that in some places it falls in the positions 3, 4, 5, i.e. it is a subgroup of 1, 2, 3. But in other cases, it is the primary group, cross-check. And again, all in the same source member. I can sequence them. I can sort them by type. So I can pick out programs, modules, and everything else. And that, I'm not going to go on and on because I'll cover this and talk about it as we go through a bit. And I think I've mentioned it up to now as well. But it is absolutely essential. And please understand, this is no joke. It is essential that you actually come to some normalized naming standard within your entire development team. And I know that that can be rough. And maybe this is again where you need to call the management and ask for their support to actually impose certain standards. Because without them, your modernization is going to become difficult. I'm not saying it's impossible, but the better your standards, the more logical your standards and the more well constructed they are in terms of naming, the easier you are going to be able to find the pieces that you otherwise won't have a direct link to. Yes, the AO product is designed to maintain these relationships despite the naming convention, so that sorry, I'm just looking for one here. Oh, there it is, sorry. I've now gone and created two. If you look at the AO workbench, we'll look at the one we're busy with here. The purpose of the AO workbench is to actually correlate, toggle all the components on, and this now relates logical files to their physicals, their keys, constraints, etc., etc. This is the design of the workbench, so that even if your naming conventions are not good, or are not kosher, or are not leaning in this direction, at least with the workbench, it'll tie the names together for you and give you a way of managing the legacy stuff. But it still means you're going to have to use this to go looking for the bits and pieces. and try to understand where you are and what bits connect to what bits. So you need to design a standard, and then you need to impose it and go forward, putting that standard in place to make your life easier. What's happened in the past and what is in the past, you do not want to create a huge project to go and retrofit names to historical stuff, because that is only going to create so much trouble and take too much time and not worth the investment. AO will help you out in that area and correlate all these things together, but you do need a standard going forward so that it becomes easy for the developers to connect the dots, which otherwise, as you can see from this, are not all that easy to connect. Once you have become 100% familiar with how all these triggers and IO servers and all that stuff works, and it becomes second nature to think like that, it gets a lot easier. But you still have to have names to make the connections. Otherwise, you have to go scrabbling for them. So I can't really stress enough the need for a consistent naming standard. I tell you, I drive people crazy with this, because to me it's a big thing. I know everybody has some sort of standard. Well, I hope. If you can accommodate or manipulate it to be more RDI friendly, is the best way of putting it, so that you can use the filters in RDI and you can sequence accordingly, and you can put it all into the same source file, and you can get it all the bits together, so much the better, if you can do that. The same source file to me is very important, and there's another reason for that. It makes sure that you don't have duplicate objects sitting with the same name in different sources. This one can cause incredible problems, particularly over a period of years. You might end up with a situation where you have two programs with exactly the same name existing in different schemas and doing completely different things. Now, I'm certain that you can see the potential disaster in that. So by bringing code into one source file, you can check for those duplicates and trap them and clean them up. You don't have to do it all by next Monday. In fact, a little bit at a time and moving in the right direction is the best way to approach it. But you do need some way of insisting. And as I said, you can set up a steering committee. You can even go through an election. I don't know, it depends how many developers you've got in your team. I know that Everett's got a huge team. They might elect people to be on the steering committee. And it's the steering committee that will discuss and set the standards. And then the people are required to they will be published, and people are required to conform with those standards. Other situations, maybe a database architect, database engineer can impose database standards and say, these are the way I will do things, and these are the way you will do things. That might be a possibility. Management, senior management might be required to put a bit of heavy into the whole situation. I don't know. The only thing I do know is without standards of naming, this becomes a nightmare, because connecting the dots becomes difficult. Now, I'm quite happy if anybody wants a list of my standards, I'm quite happy to give them to you and lay them out for you. In fact, I think I've got some on the website. I will check them and I will actually update them and I will make them available. It might give you some ideas, but you're going to have to match what you have with what you want. So I'm not going to harp on that subject anymore. I'm going to cut this whole session 10 minutes short because I've got to a sensible break point. I'd like you to send me any questions or even disagreements. If you disagree with what I've had to say, please send them to me. I keep begging. Nobody talks to me outside these sessions. So enjoy the rest of your day. Thank you for listening, and we will be picking up next Tuesday and moving forward. Thanks a lot.